So welcome to the screencast for the assignment 2 on acids and bases and salts. So first question is on whether writing the formula and stating whether it's a strong or weak acid. So I think this is similar to assignment 1, so I won't really go through this. Now question 2 is the one that I wanted to go through. Firstly, we see that Emma performed several experiments, observe the following reaction. Hydrogen chloride dissolved in water, we get something that can produce electricity. Now, so first thing you need to ask yourself is, when can something conduct electricity? We need free mobile charge particles. Okay, to conduct electricity, we need free mobile charge particles. There are two types of such particles. It can either be electrons. In the case of metals, that's what we observe. Remember, metals have a sea of delocalized electrons. And another type of charged particles that we can see is ions. Okay, so when ions are dissolved in water, they are free to move. Okay, so explain this observation and write down the chemical equation with state symbols. So whenever the question asks you to write something with state symbols, the state symbols will also constitute a mark. Okay, this part on water is a polar solvent. It's not required for you to know. Okay, so what you need to write is hydrogen chloride gas will ionize when it is dissolved in water to produce mobile. You don't need to write charge carrying also. Just write mobile, H plus and Cl minus ions. Okay, and this will be the equation. So note that the state symbol for hydrogen chloride is gaseous state. Why is hydrogen chloride a gas? It is because it is a simple covalent molecule. You may have forgotten what okay, covalent you should know what it means, but you may not know what's a simple covalent molecule. Now when we were doing your chemistry authentic task, some of you did on simple covalent molecules, some of you did on giant covalent molecules. What's the difference? Remember that simple covalent molecules have a fixed number of atoms. Okay? The atoms are countable. Whereas for a giant covalent molecule, their atoms are uncountable. Okay, so in this case, HCl is a simple covalent molecule. Simple covalent molecules typically have no melting and boiling point, which is why it's a gas. Are you required to know this? Okay, so the only example of we always only just ask about hydrogen chloride gas. We don't ask you about HNO3 or H2SO4. So what you need to remember is HCl, before it dissolves in water, looks like this. Has gaseous molecules, but when you dissolve it in water, okay, let me just zoom in. But when you dissolve it in water, you'll get in water, instead of H joined to Cl at the covalent bond, we get H plus and Cl minus. I think we saw this picture in your notes somewhere. Okay, somewhere. So initially they are gas. HCl is a gas. Here it is in an aqueous solution. Here we call it hydrogen chloride. Here we call it hydrochloric acid. And you don't need to know any other example, okay? Anything that can come out will be HCl. We always ask HCl, okay, if it comes out. Next, when it is dissolved in hexane, a non-polar organic solvent, the product was not able to conduct electricity. Explain why. So they already said to you that hexane is a organic and non-polar solvent. You don't need to know what's the meaning of the word non-polar. It will be taught to you next year. However, what you do know is that hydrogen chloride dissolved in this solvent that is not water, it cannot conduct electricity. Why is that so? Because HCl only ionize in water, okay, not in any other solvents. Since it doesn't form ions, we cannot conduct electricity. Okay, does not form ions, hence no mobile ions and cannot conduct electricity. Okay, a straight of magnesium was added to a solution formed in A. The solution formed in A being this solution, which is HCl in water. Okay, we add magnesium to hydrochloric acid. What will we observe? So this is a acid metal reaction. It should give me salt and hydrogen gas. What will be my observation? Remember, if there's a gas involved, let me just write down. Remember that whenever a gas is involved, you must first write that there's effervescence, write the color and odor of gas, then lastly, the test plus expected observation for this gas. Okay, so what will we observe? Effervescence of colorless odorless gas as it reacts, and this is the equation. So note that in the question they asked you to write a balanced chemical equation. They didn't ask you to write state symbols. So it is okay in this question for you to not have state symbols in your equation. Okay, but if you did write your state symbols, it's good as a practice. Okay, in exam, if you write state symbols, when the question didn't ask you to write state symbols and those state symbols are wrong, what would happen? Now, because the state symbols are wrong, then your concept is wrong. So even if the question didn't state for state symbols and you wrote the wrong state symbols, we will deduct marks. Okay, so kiang teo ho, mai ke kiang. Maybe you don't understand what I said. It's Hokkien. Okay, never mind. Okay, next. Straight of magnesium added to the solution formed in B. So the solution formed in B is here, the one with HCl in hexane. Note that hydrogen chloride in hexane doesn't give you hydrochloric acid. Hence, it should not display any acidic properties, and it will not react with your magnesium metal since there's no H plus ions. So there will be no observable change. Okay, we can't say that there is no reaction. So let me just write here. No observable change doesn't mean that there's no reaction. But if there's no reaction, we definitely will not observe a change. Okay, let me give you an instance where a reaction takes place but we can't see any changes. For instance, if I add HCl to NaOH, this is a neutralization reaction. It should give me the salt, NaCl, and water. Note that HCl is colorless, NaOH is colorless, NaCl is soluble in water, so it's also in aqueous state, and colorless, and water is also colorless. So when we react these two together, we should not see any change. So even though a reaction has taken place, there is no observable change. So it's not true that no observable change equals to no reaction, but if no reaction has taken place, then definitely there will be no observable change. Okay, that's a digression. So what you observe is there's no observable change. You don't need to explain because the solution is not acidic, because the question did not ask you to explain. Okay, next, question 3 is a more unique question. I think that many of you do not know how to attempt this kind of question. So first, there's two bottles. One is aqueous sodium chloride, the other is aqueous sodium carbonate. How do I have a chemical test, including observations and balanced chemical equations, to differentiate? Okay, so right now what I want to do is to differentiate between NaCl solution versus Na2CO3. So what you need to think to yourself is, what differences can they have, these two substances? First off, their state, they are both in aqueous state, so you know it can't be like filtration or something like that. It can't based on the state to determine who they are. Then you know that they are both a sodium salt, so it definitely cannot be a reaction that involves sodium. So let's see, the difference between these two lies in their anion, chloride and carbonate. Did we learn anything about chlorides and carbonates? We learned before that carbonates have a reaction. This one will not react with acid. This one will react with acid. And since carbon dioxide is dissolved, there will be effervescence, colorless odorless gas, as well as effervescence, colorless odorless gas. Then we need to test for this gas, which is white PPT when bubbled into lime water. Okay, so you can read the answer key here. Since they ask you to describe the test, you need to tell us like some steps. First, pour small volumes of A and B into test tubes. To each test tubes, we add a bit of HCl. So the test tube where there's effervescence of colorless odorless gas that gives a white precipitate when bubbled through lime water. So this part is the observations. These are the observations. Here is the chemical Bender's equation. And they ask you to differentiate between the two. What I usually will also include in my answer is to also say that if no observable change, if there's no observable change, then it contains sodium chloride. Okay. Next, hydrochloric acid is a monobasic acid, sulfuric acid is a dibasic acid. What is the difference? And I ask you to explain. Okay, so since they didn't ask you to write an equation again, you can also just write this part when you use words to describe. However, I find that when we are describing, explaining what is the meaning of a mono and dibasic acid, it is always useful for us to write the equations. With the equations is, we can tell with one look what's basicity. Here, 1 HCl gives me 1 H plus. Here, 1 H2SO4 gives me 2 H plus, which is actually the definition, right? Question 5. What are the steps in the preparation of is to titrate. You may not know what is this word. Okay, it is when we add an acidic solution to a alkaline solution and try and look for the point of neutralization. You will be doing this kind of experiments next year in Sec 3. Okay, but you don't need to be concerned. What you need to know is the reaction right now is sodium hydroxide against sulfuric acid. What will be their state symbols is written in the question. It's a solution against a solution. So they are both in equal state. So I think this is straightforward enough. You should know how to write a salt form as well as you know that water is the other product. What is the name given to this kind of reaction? It is a neutralization reaction. Next question is a definition question. What is a strong acid? Yeah, definition, so you should know. Describe a chemical test that's used to distinguish. Again, they ask you for a chemical test, a strong acid and a weak acid. Now note that when I talk about a chemical test, you cannot use litmus paper. I had some technical difficulties. Let me continue. So we cannot use litmus paper. We also cannot use universal indicator. A chemical test requires you to use a chemical reaction. So you must react it with something, and you must include expected observations in your test. Since it's a test that asks you to distinguish, you must include expected observations of strong versus weak acids. Okay, so this part is similar to what we did in the last time the question. I think assignment 1 had a similar question where they asked you to compare strong and weak acid. So a strong acid reacts faster, assuming that they are at the same concentration. So we add magnesium and we measure the volume of hydrogen gas produced in a syringe. How will this look like? Let me draw it out. So what will happen is there's this kind of conical flask, right, with a side arm. Okay, then I attach it to a gas syringe. So this is the solution and this is the magnesium. This is the acid. Okay, it's an unknown acid, right? So acid here. So what happens is effervescence will be produced and the gas will push back the syringe. Next, we have a graph. It shows the volume of hydrogen gas when a reactive metal adds to sulfuric acid. Okay, so this is the volume of hydrogen gas, is the time. So note that after a while, the graph starts to plateau. Okay, so what does it mean when the volume of hydrogen gas plateaus? If you think about it, it means clearly, since there's no more hydrogen gas being produced, therefore, the reaction has stopped. So this is the point in time where the reaction stopped. Suggest a suitable reactive metal that can be used in this reaction. Any metals will do, but 3 metals is not accepted. We cannot accept copper, silver, or gold. It's not accepted as they are unreactive. Okay, because they are unreactive, we cannot use this type of metals. Write a balanced chemical equation including state symbols. So note again, they ask you to include state symbols for the reaction between dilute sulfuric acid and the metal you have chosen. So depending on what is the metal that you've chosen, you will have a different equation. But note that the product should be hydrogen gas, and you must balance the equation. How long did it take for the reaction to finish? 6.5 minutes. We will accept any answer from 6 to 7 minutes. Okay, so if your answer is 6 minutes, you mark yourself correct. 7 minutes, you mark yourself correct. Describe the qualitative test for hydrogen gas. Extinguish burning spring with pop sound. Okay, now next they ask you to describe a simple experiment. They didn't ask you to conduct a chemical test. So this time we can use litmus paper. We can use universal indicator. Okay, to show whether something is an acidic oxide, we need to see if it reacts with an alkali. If it can react, we can test with moist red, moist blue litmus. If moist blue litmus turn red, or you know that acidic oxides can react with the easiest way is, since you know that acidic oxide is soluble in water, we can dissolve it to get acid solution. Okay, since it's an acid solution, we can react with a metal or metal carbonate. If we see effervescence, then you know that it's an acidic solution. But I will say that this is easiest lah. If a moist blue litmus turns red, then it's an acidic oxide. Okay, question 8. Just write the formula, nothing to go through. 8b, two physical property, also just read your notes. Pick any two. Okay. Question 9, table shows the pH value of 5 solutions A, B, C, D, E. Let me draw it out. So for this kind of question, what I tend to do is, again, I draw a number line, 7 here, 6, 5, 4, 3, 2, 1. Okay, 8, 9, 10, 11, 12, 13, 14. So, in the pH of 2, I have A, 7, I have B, 8, I have C, 13, I have D, 5, I have E. Which solution is neutral, strongly alkaline, strongly acidic? If it's neutral, it must be pH 7. It's neutral. Okay, the rest you can do yourself. Which pair or pairs of solution, when added together in equal quantities, would produce a neutral product? Okay, so for it to produce a neutral product, it must be in equal quantities. This means that they are equally far from pH 7. Okay, so for instance, if I have something from pH 6 and something in pH 8, I'll add them together in equal quantities. It should give me back pH 7. But if you look at all the options here, I think none of them satisfy this criteria. Okay, so actually, I'm also not sure of the answer. I think the question is wrong. So, I think the question is wrong in that for this question to be doable, this one should change to 1, and this one should change to 6. Okay. If we edit these values, then I think everything will make sense. Then, which pair or pairs of solution when added together in equal quantities will produce an acidic product? Now, if you want something to be acidic, there's two options. If I add two acidic solutions together, such as A and E, definitely their product will be acidic. If I were to add together an acidic solution and a neutral solution, acidic plus neutral, I should still get a acidic solution. Okay, same for here, acidic plus neutral solution, I should overall still get a acidic solution. Which pair will give me an alkaline product? We have the same argument where C and D, alkaline plus alkaline should still give me an alkaline solution. Neutral plus alkaline, neutral plus alkaline. It is also possible, I had also had a student ask me, what happens then if I were to add, if I were to add D to E. Because D is strongly alkaline, E is weakly acidic, overall, if you take it, add it in equal quantities, they should still give you a alkaline solution. So the same argument goes for A and C. When added together in equal quantities, they should give me an acidic solution. Question 10. What is the alkali that's added to phosphoric acid to produce sodium phosphate? So you know it's H3PO4 plus some alkali. It gives me Na3PO4. How do I get the identity here? You know that it must be sodium something, right? Because the alkali gives you the cation of the salt. So you know it must be sodium something. And since it's an alkali, it should be a hydroxide. So answer is sodium hydroxide. Write a balanced chemical equation including state symbols. Okay, so this is just it. Now, I said before that you don't need to know the solubility of phosphates, but even without memorizing the solubility of phosphates, you should still be able to write the state symbols for this sodium phosphate, because sodium salts or sodium salts are soluble. Okay, alkali used in A, gas with ammonium chloride to produce ammonia gas. What is the test for ammonia gas? So you describe the test. This part, ignore. Not tested. Okay, what is the essential step must be taken to ensure ammonia gas is evolved? This reaction should be warm. This will reduce the solubility of ammonia in water. Note that ammonia is very soluble in water, so if we don't warm the solution, any ammonia form will just be dissolved in water and we will not get an alkaline gas. Okay. Write a balanced chemical equation including state symbol for the reaction in B1. Okay, just write the equation. Oh, this is a hard question that I wanted to go through. Farmers control the pH of the soil they grow by adding calcium hydroxide. Okay, sorry, I'm recording this at home now. I stay on the second floor, so it's a bit noisy. I don't know how the audio will sound like, but it sounds very noisy to me now. Let me try and close the window. Okay, I think that will have minimal effect, but I guess it's better than nothing. So first they add calcium hydroxide. They also treat it with fertilizers like ammonium nitrate to provide them with nitrogen, which is essential for making proteins. So now, why is it that they should not add calcium hydroxide and ammonium nitrate at the same time? Okay, you may be like, huh? What is this question talking about? First, we analyze the question. Calcium hydroxide to control pH. So what kind of soil is it added to if it's used to control pH? It should be added to neutralize acidic soil. Okay, now we move on to ammonium nitrate. It is added to provide nitrogen for plants' growth. Okay, so why is it that when I add these two together, it's not good? Then you must think, will they have any reactions? Calcium hydroxide, ammonium nitrate. Okay, these two will react to give us calcium nitrate water and ammonia gas, as they ask you to write state symbols and a balanced chemical equation. So this is the equation you should write. When calcium hydroxide is added to ammonium nitrate, this is an alkali ammonium reaction, ammonium salt reaction. Gives us salt, water, and ammonia gas. So why is this bad? Note that when this reaction occurs, I have less hydroxide, I have less nitrogen. Why is it important? Why is it said that I have less hydroxide? And why is it said that I have less nitrogen in soil? Oh, okay, why do I say I have less nitrogen in soil? Nitrates are still here, but note that ammonia is a gas which will evolve out of soil. Okay, it will just become a gas and go out of the soil. So, in that sense, we are losing your hydroxide ions, so it is less effective in neutralizing the soil. Secondly, we are losing the nitrogen that is important for plant growth. So because calcium hydroxide has reacted and removed from the soil, it cannot regulate the pH of the soil. Ammonium nitrate has reacted to give ammonia gas, so we have some nitrogen being removed from the soil. So if we add these two together, they counter each other, they react with each other, such that it loses their original function. Okay, so that's why we should not add them together. Question 12 shows the color of some common indicators at different pH values. So this is another way we can represent the pH of indicators when they change color. Another way is the one that we see in our practical, where they tell you the indicator color changes and pH range it changes color. Remember? So like without orange, color changes is red, orange, yellow. Then over here, the pH range is 3.2 to 4.4, I think. Can't remember. Okay, so here the pH range that change color is in the middle color. Anything before that is red, anything after that is yellow. So this is how we interpret that table. For this table is a lot more straightforward. Okay, for instance, what color will a solution of pH 3 becomes when we have bromo crystal green added to it? pH 3, circle the pH, bromo crystal green, this indicator, draw an arrow down, you'll see that it is yellow color, so it is yellow. What color will it be when a few drops of phenol red, pH 7, pH 7 is here, phenol red is here, draw a line down, it is red color, so it is red. Solution turns yellow when either methyl orange or phenol red is added to it. What's the approximate pH of the solution? So if you look at methyl orange over here and phenol red, you see that the range that it changes color in is yellow in. The part that overlaps is here to here. Okay, do you see that that's the range that it overlaps? So that will be around 4 to 6. So any values from 4 to 6 will be accepted. a mixture of all four indicators is added to a strong acid, what will be the color of the resulting mixture? Now, if it's a strong acid, you need to look at the low pH range. Strong acid should be the colors here. I have red, yellow, yellow, colorless. If I mix red, yellow, yellow, and colorless together, what will be my resulting color? It should be orange. Complete the following table. So we just need to look at the name to write the formula. Nitrogen dioxide, that means there's 2 oxygen to it. Okay, you think about it, it's a non-metal oxide, so it's either acidic or neutral. It's not one of the 3 that's neutral, so it's acidic. So on and so forth, you fill out the whole table. Describe how you obtain a pure sample of copper 2 oxide. A mixture of copper 2 oxide and zinc oxide. Okay, again, this kind of question you may not see it very often, so you need to think copper 2 oxide and zinc oxide. Are they soluble? No, they're both insoluble. Okay, so it's a mixture of powders. Then you must think, have I learned anything that can separate these two? Anything different about these two? You should know that this is a basic oxide. This is amphoteric. Are there any difference in their reaction? I know that this reacts with a alkali, but this does not react with alkali. Okay, so that will form the basis of what are you reacting with. Okay, so copper 2 oxide will react with, you should write will not react with alkaline solutions, but zinc oxide will react with alkaline solutions. So that's the basis of our experiment. How do we obtain copper 2 oxide? We add an alkali, okay, to the mixture. Then zinc oxide will dissolve because it reacts with alkali. Copper 2 oxide doesn't react with alkali. It remains the same. It remains insoluble. So now we have a solution. Copper 2 oxide. Here we have a solution that's made of the dissolved, the salt formed by zinc oxide and the sodium hydroxide and water. So you just need to filter it and we get this part, copper 2 oxide. Then you may ask me, do I need to write this whole part? Okay, you need to write up to whether it is the residue or the solution. Because they mention to get a pure sample, it also excludes water. So if your sample is wet, it is also not a pure sample of copper 2 oxide. So we try and dry it first. First, we wash it with distilled water to make sure it's clean. Then we dry it by pressing it against layers of filter paper. Not to worry if you miss out the part about drying it and washing it with distilled water. I think you'll still get full credit because we have not yet taught this kind of question to you. Okay, this is actually a bit on salt preparation, okay, which is not taught to you yet. Okay, but note that this is a bit of your separation technique. So even though we did not explicitly say that separation technique can be tested in exam, it may still come out in questions like this. Okay, so please revise carefully, and that's all. Thank you. It's a very long screencast.